of a square minus x square dx. Already we did it, and we mentioned the formula for this integral of root a square minus x square dx using substitution of trigonometry. Okay, using trigonometric substitution I mean. And now I am going to find its integral value using integration by parts. After deriving this using integration by parts, I am going to mention two more formulas. That means this is integral root of a square minus x square. In the same way, what is integral of root of x square minus a square, as well integral root of a square plus x square. All these things and some simple problems related to those results I am going to mention now. You just look here, integral root of a square minus x square dx. I am not moving with the substitution. I am just trying to move with what? Integration by parts. So to move with integration by parts, what we need? Integral of 1 into root of a square minus x square dx. Since my target is to use this integration by parts, I need two functions. Okay, I need what? Two functions, and only I have one function as root a square minus x square, and the other function I am treating it as 1. So now what I have? I have integral 1 into root of a square minus x square dx. So now what is first function? What is second function? You just take this root of a square minus x square as first function and this 1 as second function. Why? Because if you consider this 1 as the first function, after applying you need to mention the derivative of first function, which becomes 0, right? So don't take it as first function. Okay, anyway, this is first function f, this is second function g, and integral of the product f into g. Okay, what it is? F into integral z dx minus integral f dash into integral z dx and this total part dx. Okay, this is the formula for product of two functions, integral for the product of two functions. If we took 1 as first function, this f dash will become 0, so this term will become 0, then there is no way to solve. Okay, and now this is equals to f, which is what it is? Root of a square minus x square into integral of z dx. What is integral of z dx? Integral of 1. Integral of 1 is x, right? So x. Root of a square minus x square into x. Okay. Minus integral of f dash. What is f dash? Derivative of this root a square minus x square. See what you say about the derivative of root something. Derivative of root is 1 by 2 root. So 1 by 2 root of a square minus x square into derivative of this a square minus x square, which is 0 minus 2x, into integral of g, integral of this first function, integral of 1 is x dx. Now we just cancel out these two, then we left with this is equals to x root of a square minus x square, minus of minus is plus integral x by root of a square minus x square dx. Not x, it is x square. Okay, then what is the next step to solve? Here in the denominator we have root of a square minus x square, but whereas in the numerator we have just x square. Okay, so how to solve this? For that I go with a simple logic. See, initially you just take this root of a square minus x square dx value as some I. You just take this value as some I. So that I is equals to this integral 1 root of a square minus x square, and at the end I have I is equals to x root of a square minus x square plus integral of x square by root of a square minus x square dx. Now my task is to find the integral of this. This is a bit different one. We have no way to answer it directly, and that's why I am going to rewrite, I am going to manipulate it to get integral value in a simple manner. For that what I do is, the first step I use minus sign here as well minus sign here, and the next step, since I have a square minus x square in the denominator, I will add 1 a square and I will subtract 1 a square in the numerator. Okay, finally what we have in our hands? This I is this integral value. Our task is to find I at the end. So now I is equals to, what is this part? This part is x root of a square minus x square minus integral of, now look here, since it is minus x square, you just keep it like that, add 1 a square and subtract 1 a square. So what I do is a square minus x square minus a square divided by root of a square minus x square dx. Anything wrong? Nothing. Okay, nothing is wrong here. Okay, why? Because we just added one a square and subtracted one a square, and now I is equals to x root of a square minus x square. Now you just simply split it. So a square minus x square by this root, minus of minus plus a square by this root. So this is minus integral a square minus x square by root of a square minus x square dx. Minus of minus is plus integral a square divided by root of a square minus x square dx. Now you just observe very carefully. See, you just, if you pay attention here, this a square minus x square divided by root of a square minus x square. See what it is. What it is. You just think about it. See, there is a chance of cancellation. Something like 2, if I say 2 by root 2, it is root 2, right? So this a square minus x square by root of a square minus x square, if you cancel out, this root will cancel this numerator for root of a square minus x square times. And now this term is simply integral root of a square minus x square dx, which is nothing but given problem, and that is again I. That is again I. So what we have at the end? I is equals to x root of a square minus x square minus I plus, keep this a square out, integral 1 by root a square minus x square dx. Send this I to the left side. I and this I will become 2I is equals to x root of a square minus x square plus a square into integral of this 1 by root a square minus x square dx, a standard formula which is nothing but sine inverse of x by a plus some integration constant. This is 2I. What we need? We need I, right? So at the end I is equals to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a plus c. So finally I is this integral root of a square minus x square dx, and that integral value is x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. And this is just simply by using integration by parts. Already we did it using trigonometric substitution, but now this time using integration by part. At the end we need to memorize this integral value for root of a square minus x square as this x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. Okay, just observe this, observe the derivation and try to memorize the result what we are getting. And just look at that. Finally what we have? This integral root of a square minus x square as x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a plus c. Okay. In the same way now it is easy to derive these two using integration by parts. Integral root of x square plus a square dx. This is nothing but in the same way x by 2 into root of a square minus x square plus a square by 2 into sine h inverse of x by a plus c. We will get what? A square by 2 into sine h inverse of x by a plus c. And see, as I mentioned you previously, sine h inverse is not required for Jee Main Advanced. We need to rewrite this sine h inverse using logarithmic form. So this is again equals to x by 2 into root of a square minus x square plus a square by 2 into logarithm of x plus root of x square plus a square plus c. This sine h inverse of x by a is nothing but logarithm of this x plus root of x square plus a square. In the same way, there is a chance to derive this integral root of x square minus a square dx. What it is again in the same format? See, just a minute, okay? This is x square plus a square, right? We need to write x square plus a square only here, not a square minus x square. Okay, that's good. And now, see, integral root of x square minus a square. So now this time this is x by 2 into root of x square minus a square by 2 this time, and cos h inverse of x by a plus c. Again, instead of this cos h inverse, we need to use logarithmic notation. So x by 2 into root of x square minus a square by 2 into logarithm of x plus root of x square minus a square plus c. You just try to memorize these three results. Okay, 1, 2, 3, and everywhere the first term is of symmetrical form, x by 2 into that given function. Okay, for the first two plus a square by 2, and for the last one is here minus, so minus a square by 2. It is sin inverse x by a, this is sin h inverse, and the last one cos h inverse. And we know the way of rewriting sin h inverse in logarithmic form like this. In the same way, cos h inverse as a logarithmic notation like this. Just observe this, try to memorize this and use this to answer some questions. Just try to answer these two simple direct problems using the above results. Okay, and in the next class my concentration is completely about way of answering different problems related to all these results. Okay, and now what is integral root of 9 minus x square dx? Simply this 9 is nothing but 3 square, right? So this is integral root of 3 square minus x square dx. So just it is of the first format, but a is 3, so rewrite it. This is equals to x by 2 into root of a square minus x square, means 3 square minus x square, that in the sense 9 minus x square, plus a square by 2. A is 3 and a square is 9, so 9 by 2 into sin inverse of x by 3 plus c, just because a is 3. Okay, this is that much simple to write answer for this root 9 minus x square if we are well about the first result. And in the same way, root of 16x square plus 9. To answer this, x square coefficient should be 1. Okay, here I have 16x square. What I do is I will pick out 16 as a common thing. If you pick out 16, x square plus 9 by 16, and 16 coming out of the root will become 4. So this is nothing but 4 into integral root of x square plus, see 9 by 16 is nothing but 3 by 4 whole square dx. Just observe this. I am just rewriting this 16x square plus 9 as 16 times of x square plus 9 by 16, and that is x square plus 3 by 4 whole square. This 4 is a constant, just write it out. And now this root of x square plus 3 by 4 whole square, our a is now nothing but 3 by 4. What a is 3 by 4. Use this result, x by 2 into root of x square plus a square. So x square plus a square is 9 by 16 plus a square by 2. A square is this 9 by 16 by 2. That in the sense 9 by 32 sin h inverse of x by a. A is 3 by 4. X by 3 by 4 is 4x by 3 plus c. That's the way to answer these type of questions using these results. Okay, have a look. And in the next class we are going to discuss different problems related to all these things. Okay, and that's for today's class. And now finally, to be good at this indefinite integration, you just watch and learn all our previous video classes as well, the next video classes also. Okay, right. And then do like this video, don't forget to share it for your fellow aspirants, as well encourage your friends and fellow aspirants to subscribe for this channel. Thank you.